Good morning. All right, what we're going to do for these last 2 weeks, hallelujah, this is almost over, right? We got just a couple more weeks left, um, is do some work with what's called rational expressions. This is something you'll be working on in pre-cal, near the beginning of the year somewhere, but it is another way for us to review factoring. Okay, again, I expect you to have mastered factoring, and so here we'll be reviewing some factoring as we do this. So first of all, with this, we're going to look at what is a rational expression today and how to simplify it, and then we'll look at some operations with rational expressions. So these are not equations. We're not solving for anything. We're just simplifying some expressions. So what is a rational expression? All right, so it's an expression with a variable or variables in the denominator. All right, so if that means we have a denominator, that means we're looking at things that look like fractions. So, some examples of what a rational expression is. 2 over x. There's a variable in the denominator. That's a rational expression. X over y. That's a rational expression. So we'll be looking at some more complex ones like this, like x squared plus 3x plus 4 over x squared plus 4x plus 1, and we're going to look at how to simplify with this. So first we're going to write out our steps. Alright, so step 1 is to factor all the expressions. Everything that's in the numerator, everything that's in the denominator. If you can factor it, you will factor it. Then, because we're looking at fraction, when we simplify, we always want to find what we call domain exclusion. So I know we don't have a function here, but if we were to make this a function, we would want to know what those are. And we still, if we're plugging in numbers, have to be able to get an answer. So when we're looking at fractions, whatever makes the denominator equal to 0 is not part of the domain. So we call it a domain exclusion. And then you're going to simplify any common factors. Now what that means is you're going to look for expressions that are the same. And then we're going to simplify them. And you know I hate these terms, but I'm going to go ahead and use it because that's what a lot of you like, is that we're going to cancel out. So I'm a little nervous with using those words because that's not what that really means, but we're simplifying, and that's the way you think about it, is canceling them out. So if you follow these steps, you'll get to the right answer. Now I'm going to go ahead and tell you a big misconception. So I'm going to go to another sheet for a second. A misconception is something that somebody thinks is the right way to do it, but it isn't. Alright, so let's say we have x squared plus 1 over x squared minus 1. Now my rules tell you to factor everything first. But I got these people won't say what kind of people, that like to say, I'm not going to follow those rules, and I want to cancel out first. And they do this, and they say that's -1. That's the answer. That is not the answer. That does not simplify to -1 at all. You cannot simplify just this x squared or just these ones, because this is one whole expression. These aren't separated. So anything that is joined with addition or subtraction cannot be simplified separately. It has to be simplified as one whole big expression. So I'll show you that with some examples, but this is a big misconception. That means that's a big no-no, what I just did there. So, boo, don't do that. All right, let's go through some examples. All right, so first thing we want to do is factor. That's what you do first. All right, in the numerator, there's a GCF, so I'm going to do that first. So there's a GCF of x squared. There were 3 x's. I took 2 out, and then plus 1. X plus 1 is prime, can't be factored. That's step 1. Step 2 is to find domain exclusions. What's going to make this denominator equal to 0? Well, -1 will make that equal to 0. So down here where I'm going to put my final answer, I'm going to write my domain exclusion. That x can't be -1, because if x is -1, then this is undefined and I can't do anything with it. Anything else will be fine. Then I'm going to simplify any common factors. That means expressions, right, or things that are put together with addition and subtraction that are the exact same. So x plus 1, this expression, and this expression, x plus 1, can be simplified as one whole expression. So x plus 1 divided by itself is 1, and that's why I can simplify that. And so that just leaves me with x squared. So what we're doing here is we're finding a more simplified, because we're simplifying, way to write this expression. So here's kind of a way to check yourself. These two things will give you the same answer. We haven't changed it. We just wrote it a different way. So if I pick a number, any number besides -1, and I substitute it into this expression, I should get the same answer as when I substitute it into this expression. So for instance, let's say 2. So I'll plug in a 2 here. And I get 4. All right, if I do 2 squared, the answer is 4. So no matter what I plug in for x, as long as it's not -1, I get the same thing. So this is just another way of writing it, like taking the fraction 2/4 and writing it as 1/2. They both mean 0.5. So that's what we're doing here. All right, so let's look at another example. All right, so first step is to factor. Here I'm going to use reverse FOIL. X and x, same sign, both plus. Multiplies to 5 and adds to 6 would be 5 and 1. Denominator is difference of squares, so that factors into x plus 5 and x minus 5. Now, before you go crossing anything out, you got to find your domain exclusions. Before, because that's step 2, you do this before you cross or cancel anything out. So what makes this expression equal to 0 is -5. So x can't be -5. What makes this is 5. So you can write this 2 ways. You can write -5 or 5, or we wrote this before, plus or minus 5. Either way you want to do that. You can write it either way. All right, then simplify. So we have an x plus 5 and an x plus 5, so we can simplify or cross those out, and we're left with x plus 1 over x minus 5. Meaning besides 5 or -5, anything I plug in here will give me the same thing as what I plug in here. A more simplified way to look at it. All right, let's look at a couple more. Right here, this is a difference of squares, so that's going to factor into x plus 1, x minus 1. Here, reverse FOIL, what multiplies to 1 and adds to 2 is going to be 1 and 1. So what makes these expressions equal to 0 is negative 1. And then I can simplify a set of x plus 1s, and I'm left with x minus 1 over x plus 1. Alright, let's look at two more examples. Alright, x cubed minus 1 is a difference of cubes, so let's review that. So that's where we put our two expressions. We use SOAP for our signs. Same, opposite, always plus. Cube root of x cubed is x. Cube root of 1 is 1. Then we multiply the x by itself. X and the 1 by itself. And you should have a foldable if you've forgotten any of your rules. And then x minus 1 won't factor. Then we find our domain exclusion, so x can't equal 1. We can simplify our x minus 1s, and we're left with x squared plus x plus 1. And the last example. Alright, so here, when I look at it, I see some GCFs. So remember, when you're factoring, sometimes you have to factor more than one time. And the first thing you should always look for is a GCF. So my GCF here is 2. My GCF here is 4. But then this is a difference of squares, so I can continue to factor. So you want to factor completely. So that's going to factor into x plus 2 and x minus 2. Alright, then we find our domain exclusions. So nothing's going to make 4 0. Negative 2 will make that 0. Positive 2 will make that 0. So x can't be plus or minus 2. Then we simplify. So I know I can simplify those x minus 2's. But now I've got some numbers here that will simplify. So 2/4 simplifies to 1/2. So in the numerator, the only thing that's left is a 1. And in the denominator is a 2 and then an x plus 2. And you leave it like this. Like you don't multiply things back together or anything. That's how you'll leave your expression. Alright, so please message me any questions you have on this. Hopefully you'll do well. You'll remember how to factor. And we'll practice this for a couple of days and then go from there. Hope you have a great day. Bye.